Hi guys, my name is Shelly and I'm someone who really likes chemistry and math. My goal for this channel is to help other people enjoy these videos as much as I did. I plan on making explanatory videos as lighthearted and easy to digest as possible. The current focus on this channel will be organic chemistry since I am an Orgo TA and tutor. I hope you guys enjoy my videos and learn to love my favorite subjects like organic chemistry, biochemistry, calculus, and more. Thanks for stopping by! Before we begin organic chemistry, we need to have a solid foundation of general chemistry. In my opinion, I don't think there is much overlap between the two, but it is good to have a solid base nonetheless. Speaking of bases, the importance of acid-base is crucial in organic chemistry. This is because the acidity characteristics affect stability, reactivity, and the positioning of a compound during a reaction. We know the ability to be acidic reflects how easily the compound will donate its protons. A highly acidic compound will essentially start freaking out to donate or lose its protons. We can quantify this using Ka, where this equation is used. Note that these brackets indicate their concentration values. This equation will give you the Ka. However, some organic chemistry questions might ask you in reference to the compound's pKa, in which that case, the pKa is inversely related to Ka. With this, a stronger acid will have a high Ka but a low pKa, and a weaker acid will have a low Ka but a high pKa. Therefore, when given an acid-base equilibrium, the reaction will favor the weaker acid, a higher pKa, because it is less reactive and therefore more stable. Moving on to being able to rank acid strength, I want you to understand how important the phrase, "the strongest acid has the most stable conjugate base" is. Because if the acid is strong, its respective conjugate base cannot be strong as well. Therefore, I want you to think of the conjugate base as a sad sack that carries a leftover negative charge and seeks stability. There are 6 categories that can help you determine what is more reactive. These categories will analyze the compound's charge, size, resonance, electronegativity, induction, and hybridization to help you decide what is more acidic. We can speedrun its characterization categories. In reference to charge, acidity increases when there is an increase in positive charge. Therefore, a conjugate base would prefer to be in a more positive environment, so we can rank acidity based on that factor alone. For size, recall that atoms have an electron cloud or an orbital around them. By having the atom size be bigger in its conjugate base form, they are less squished together and are happier. Bigger atoms spread out negative charge better, which means with more space and therefore bigger atomic radius, they are more stable, which then, in return, makes them more acidic. Resonance. You can think of it as the ability to move electrons around. If there are atoms nearby that allow you to jump around and not concentrate your quote-unquote burdens in one spot, they are also more stable. Electronegativity is the ability of an atom to attract electrons. If an atom does not want to let its partner go, you can bet that their relationship is stable. Induction is caused by electronegativity, but think of it as your reliable neighbor a few streets down, rather than someone directly in your household. It is an indirect stabilizer. If some of your electrons' sadness density can be lifted by your friend down the street, you also note that the conjugate base is stable, and therefore the acid is strong. And lastly, hybridization. I will go over more of the organic chemistry part of hybridization in a later video, but recall that s orbitals touch directly and p orbitals touch indirectly. If you have more of a direct contact, such as an sp hybrid, the closeness will make you feel safer and more stable relative to an sp2 or an sp3, which has more of an indirect contact. Okay, speedrun is over. To summarize, you can think of a conjugate base as a sad electron cloud. If they're able to exist in a more stable and a secure environment, you can rest assured that the positive acid is strong and happy. Being able to rank acidity is a core concept in organic chemistry, and I hope this video helped you decide how to analyze a compound's reactivity.